All right, so this will be, what is it, lesson 3? Is that right? That's right. Lesson 3, solving equations. So lots of different equations, and that's what's fun. Get back to my medium chisel here. That's better. All right. So we're just going to straight out just go ahead and do some solving. We're not going to do a whole lot of background work here because you've been doing this for years. So let's start with something fairly simple. And we're going to try to solve these equations. So when you're solving equations, what's your main goal? Get the variable by itself on one side. Okay. So for this problem, what would be a good first step to get that variable by itself? All right, distributing 6 because that looks like distributed property on the left side, right? So that's a good idea. So that's going to be 6n plus 30. 6 times n is 6n. 6 times 5 is 30. And then what's the next step? What needs to move? So move the 30 over there to get it with the 2. Why move the 30 and not the 6n? And what about the 30 and the 2? They're alike. They're both just regular numbers, so they're like terms. So we're trying to get all the regular numbers over to one side and all the variables on the other side by themselves. So that's going to be 6n is equal to negative 28. Right? Divide by 6. Now, 6 doesn't go into 28 evenly. So what do I do? What can I do? And well, I don't want to go to a decimal. Simplify it by doing what? 2 goes into both of them. 2 goes into negative 28, negative 14 times, and into 6 3 times. So that'd be negative 14 over 3. And that's how we want to leave our answer, as an improper fraction, but reduced as far as it'll go. Okay. My rule is that you should, if there's not a decimal number in the original problem, don't put a decimal number as an answer. Okay. So like this problem didn't have any decimals in the original problem, so we were going to, if we didn't get a nice number as an answer, we're going to leave it as a fraction and just simplify as far as we can. So my rule is no decimal in the original, no decimal in the answer for that. Okay, so just reduce your fractions as far as you can. No mixed numbers. Don't change to mixed numbers either. Okay. All right, let's look at one that's maybe a slightly more complicated. This is Algebra 2, so we don't want to spend a ton of time on really, really easy problems. If you can do these, you can do the super easy problems. But this one looks a lot more complicated because it's got the big fraction on the left-hand side. But we know that fraction really is just what? Division. Okay, so what would be a good first step for this problem? Okay, we could distribute the 3 to the parentheses. That would help a little bit. So that's going to be 15 minus 9x, still over the negative 4, is equal to negative 15. And then now we have to do a certain thing next. Why would we do that? Yeah, they're dividing by negative 4. The inverse operation for division would be multiplying. And if I multiply both sides by negative 4, this side, that negative 4 on the bottom cancels out then. And it leaves me with 15 minus 9x is equal to positive 40 and 20 is 60. And again, you can use a calculator while you're doing this. I'm trying to force myself not to, so that I'm just helping myself with my number sense a little bit. So just use a calculator as you need to, but try to do it without it as much as possible. All right. So that got rid of that big fraction looking thing. So it looks a lot less complicated now. So what's the next step? Move the 15 by subtraction. negative 9x is equal to 45. And divide by that negative 9 is negative 5. Final. How can I check to make sure that's the right answer? Put it back in for x in the original problem. Make sure it works out to be the same thing. Okay, and it does for this one. That is the right answer. Good job. All right. That's 2 parentheses 2 minus 7x minus 5 is equal to 111. What would be a good first step for this? Distributed property would be something be good to do there. So that'd be 4 minus 14x minus 5 is equal to 111. Now what? Yeah, I got like terms on that left-hand side. I got 4 and minus 5. So together that would be negative 1. And then like terms, I add the 1. So that works out nice. And then that'd be 112. And the last step is divide by that negative 14. Negative 8. Good job. So, been doing this for years. It's nothing new to you. Just be careful on your arithmetic. Don't make simple mistakes on your arithmetic. Let's throw some fractions in there, because everybody loves fractions. Oh, you don't? What? Can't believe that. All right, so negative 16 is equal to negative 15 over 16, parentheses 4/5 x plus 32 over 3. So a lot of fractions and not too pretty ones here. They've all got a different denominator, so that means we'll have to do a little bit more on this one because none of them have the same denominator. It'd be much easier if they all had the same denominator. But now, I will say that there's a little bit of a trick to this one to make it a little easier at some point, but
I don't know how to make it a fraction on the calculator.
Yeah, me neither.
I'm going to show you. I'll show you how to do that in just a second. So, yeah, I'll show it to you again today. I'll try to demonstrate all that stuff as we go along here. That definitely a valid question because it takes a little while to get used to the big calculators. All right, so let's first talk about the trick that can make this a little bit easier. Instead of on the right-hand side, what's your first instinct to do? Distribute. And yeah, well, you could, but I don't think it really helps that much to do that. If you distribute here, you're going to end up having to multiply two fractions by another fraction, right? Okay, so instead of doing that, could I get rid of the negative 15 over 16 that's in front of the parentheses? I can't add it because what's it doing to the other side? It's multiplying, so the opposite of that would be dividing. So dividing by a fraction is the same thing as multiplying by its reciprocal. And if I do that, then I only have to multiply this negative 16 over 1 times a fraction. Instead of having to multiply two fractions times another fraction, I'm only multiplying one thing times another fraction because this cancels that out. And all I've got left is 4/5 x plus 32 over 3. And then on this side, now I'm going to use a calculator to help me do this, okay? So this is where we're going to remember how to do this with the calculator. So with the graphing calculator, in order to get it to do a fraction, you can use the division symbol to simulate a fraction and then get it to turn it back into it. So that's the way I'm going to do it first. Then I'll show you how to do it with the fraction button part of that. So with the division thing, I'm doing 16 divided by negative 15 times negative 16. So that 16 divided by negative 15, that was the fraction that I'm multiplying by, and I'm multiplying that times negative 16. And it gives me this decimal answer back. Then to change that into a fraction, I hit math, enter, enter. Okay, and that's 256 over 15. And I'm just going to put the negative out in the front there. Now, so the other way is to use the fraction button. And with the graphing calculator, it has a fraction button. It's just kind of hidden. You got to hit the green alpha button, which is right there on the left-hand column. And then I'm pressing the Y equals button, which is the very top left button. And it should bring up this menu if you're using the TI-84. And the first option is the fraction option. And I would put 16, negative 15, and then I'd press the right arrow key to get out of that fraction times negative 16. I don't know why I put a negative on that answer a while ago. That's not negative, it's positive. Because it's negative times negative. Okay, so the fraction button on the calculator or the division symbol, both ways get you a fraction answer back. The difference is, pushing buttons at the beginning or pushing buttons at the end. It doesn't matter which way you do it, you get the same answer. Okay?
Is there any way to clear like just one number instead of clearing the entire thing?
Yeah, there's a delete button right up here. Right beside the blue second button.
Oh, wow.
Look to the right. That DEL is delete, and you just move the arrow to whatever you want to delete and hit that. It's like a delete key. Good question. All right. So that gets us a little bit closer to getting done. Not quite, but it's closer. What would be our next step for this problem? Yeah, subtracting the 32 over 3, because this is the part that doesn't have the variable. So we're going to subtract that. And I'm just going to do that with the calculator there. 256 over 15 minus 32 over 3. And I'm going to go math, enter, enter. 32 over 5. Okay. If you were doing that without the calculator, you would need to get a common denominator. And to do that, you multiply everybody by 5. And that changes that problem into 150, negative 160 over 15. And then you're subtracting 160 from 256. And then you got to reduce that fraction. So, but I'm okay with using the calculator there to get that answer. That's fine. Now, one more step and we're done. What do we do? Divide by 4 over 5 is the same thing as multiplying by 5 over 4, the reciprocal. And the reason that I'm doing that is because that actually works out really nice where I may not even have to do anything with the calculator here. Because what are my rules for multiplying fractions? I can cross cancel, right? So this 5 up here is going to cancel that 5 down there. And that works out real nice. And then 4 and 32, 4 goes into itself once and into 32 8 times. And it's just 8 over 1. Or 8, bless you. So x is equal to 8. All of that ugly fraction to begin with, and we get 8 as an answer. Which is typical math stuff. Okay. So fractions are going to be the harder part just because they always are, always have been probably. Just takes working with them and practice. That's all it takes to work with fractions and to be better at them. Okay. Let's look at one that doesn't have fractions, kind of ease up a little bit here. 10x minus 7 is equal to 21 minus 6x. We'll get one with variables on both sides this time. So This one, a little bit more difficult to decide what to do first. It really doesn't matter what you do first. My usual steps are to move the things that don't have a variable first. But it doesn't matter. Honestly, as long as what you're doing is mathematically legal, it doesn't matter what order you do it in, as far as moving either the 6x or the 7 is what I would look at doing. I actually would probably do both of them at the same time, because I'm trying to get what on one side, the variable, and everything else on the other side. So when I look at that, I think about moving the 6x because the 10x is already positive. So how do I move the 6x? I would add 6x to both sides, and that's going to cancel it out over there. How would I move this 7? I would add 7 to get it to the other side. So I'm doing 2 steps at once. It's Algebra 2. I hope you can, okay? Because I'm fine with that. In Algebra 1, I would make you write 2. Folks that had me for Algebra 1 know it was 2 separate steps. This is Algebra 2. I'm expecting us to go a little faster, and doing 2 steps at once is absolutely wonderful and a good idea. So that'd be 16x is equal to 21 plus 7 is 28. And then last step, divide by 16. So shortens it up quite a bit. And then 16 doesn't go into 28 evenly. But what does? 4 goes into both of them. 4 goes into 28 and into 16. 4. And here's the thing, if you use your calculator, then you do 28 divided by 16, and then hit math, enter, enter, it'll reduce that fraction for you. Okay. If you use the fraction button, alpha y equals 28 over 16, it'll reduce it for you like that. Okay, so keep in mind that you have that tool that you can use. I hope that we try to understand how to do it without it, but I know you guys have had it in your hands for quite a long time, so it's hard to break that habit sometimes. I'm just gonna go right beside that and do the next one. 5 over 6 w plus 21 was negative 1/3 2w minus 9. This one looks kind of like example 4 did, because we got that distributed property looking thing on the other side. But I don't know if it really would help us to do the little trick that we did on the example. Yeah, and the left-hand side has a couple of things on there. So we're going to have to multiply 2 things by that fraction anyway. So I think maybe just go ahead and distribute would be the best first step on this one. I don't think it really helps us much to do anything different there. So negative 1/3 times 2 would be negative 2/3. And what's negative 1/3 times negative 9? Positive 3. Negative times negative is positive. 1/3 of 9 is 3. And now we got stuff. This looks a lot like example 5 once I get to this red line here. Okay, by doing what? Nope. I'm going to have to add 2/3 w because it's got a like term on the other side. It's got another thing that's got w. So I'm going to add 2/3 w to the 5/6. 2/3 is the same thing as 4/6. 4/6 and 5/6 would be 9/6, which is 3 over 2. And I am writing an extra step in this one just for the heck of it. It really doesn't matter. But with all those fractions going on, I think sometimes it's easier just to do 1 step at a time. Yeah, then we would subtract 21. Good job. 3 over 2w, negative 18. One last step. Yeah, multiply by that reciprocal, 2/3. And I can cross cancel a little bit with that. 1, -6, that'd be -12. And if I did that with a calculator again, I'd just say -18 times 2 divided by 3. There, get that. Nothing too bad right there. It's pretty good. Number 7. All right. 1 plus 3x equals 5, parentheses, 1 minus x plus 8x. That'd be a great idea. Anytime I see that parentheses with a number outside, that just triggers a distribute. Get that out of the way. Okay, on the right-hand side, we got like terms, the -5x, positive 8x, be 5 plus 3x. Now, what happens when I try to get the x's together? They cancel each other out. So when I subtract 3x from both sides, they cancel each other out, just like you said. And I get 1 is equal to 5. Does 1 equal 5? Never, right? So that would mean that this one is what? No solution. Yeah, it's probably been a while since you've done that. Doesn't happen too often in geometry class for sure. This is a no solution situation. No solution can happen when the variables all cancel out and what you're left with is not true. We were left with 1 is equal to 5 and 1 never equals 5. So that's a no solution. If it were equal to like 5 equals 5, then is that true? Yeah, then that would be an all real numbers situation. Okay, so when the variables all cancel out, that's the only time we could have no solution, is if the variables completely cancel out. Okay, here the 3x and 3x canceled each other out. We were left with 1 and 5. They don't equal each other, so that's when it's no solution. Let's look at number 8 here and see what the difference in it and 7 was. 40 minus 8x equals -8, parentheses, x minus 5. Distribute would be again the first step. And then when I get the x's together, they cancel each other out, and I'm left with 40 equals 40, which is true. And that's where you say it's all real numbers. Okay. All the variables cancel out. It's true. What's left is true. Then it's all real numbers. If all the variables cancel out and what's left is false, then that's when it's no solution. Those are two special cases with equations that comes up. They don't come up that often. So if you're looking at homework or a quiz, you're getting 3 or 4 of them like that, you're probably not doing something right. Something's wrong, because that doesn't happen very often, especially inside of a math class. We're trying to get you to work out and solve for things and get the answer. We're not going to give you a ton of them that have no solution or have all real numbers as a solution now that. So it shouldn't happen very often, but it could happen. So you got to be careful of that. All right, so let's get into some problems like you've done in the past, maybe more recently if you had geometry not long ago. It does. So not just in geometry that you do proportions, but I know you do this in junior high math too, and Algebra 1. We do this in Algebra 1 as well. So may have been a while, but it's doable. How are we taught to normally solve these types of problems? You might remember.
Isn't that like 3
And yeah, that's right. That's the right way. It's called cross multiplying. That's exactly the right way. So it's bottom times top and bottom times top. So on one side, we're going to say 3 times 2, which is 6. On the other side, we're saying 5 times x plus 4. And I'm writing that extra step in there, but you can go ahead and distribute. Yeah, you can just go ahead and distribute if you want to and get 5x plus 20 is equal to 6, which is pretty easily done. Now what? Subtract 20, negative 14, and then last step's divide by 5. That's yeah, it doesn't change because that doesn't simplify or go evenly. So we're just going to leave it as that nice, beautiful fraction there. So cross multiplying, when it's a fraction equal to a fraction, that's what you're going to do. That's and we're going to see more complicated problems later on in the semester. It's probably sometime around March or April that are much more complex, but it's the same idea. You got a fraction equal to a fraction. You just remember cross multiplying, you got it. Let's do one that's a little tougher. Not quite as tough as what we'll get to later on, but still a little tougher problem. 10 over 5x minus 9 is equal to 8 over 2x minus 8. Yeah, so distribute. So it'll be 20x minus 80. So I'm just distributing there in one step. And then start getting the like terms together. So I'm going to move the 72. That's not the only way to do this. And then I'm going to subtract the 20x and get negative 8 is equal to 20x. Yeah, that works too. You're going to get the same answer at the end. It doesn't really matter which direction you go there. I just did it this way just because I got to make a choice. So that's the choice. Yeah, I did 2 steps at once there. But if you move, wherever you're moving x's to one side, numbers to the other, it really doesn't matter which side you put the x on or which side you put the regular numbers on. A lot of people really like to put the x on the left-hand side. And that's probably what you've been doing for years and years. But I want you to understand it really doesn't matter which side it's on. So last step would be divide by that 20. And we're going to reduce that fraction, be negative 2 over 5. Yeah, negative 2/5 out of that. And if on the calculator you went ahead and you did negative 8 divided by 20, and it got you this decimal back, hit math, enter, and it'll give you that fraction for that. Just reviewing how to get those things done. Pretty easy thing. All right, so solving regular equations, get x by itself, solve. If the x's all cancel out and what you've got left is false, what is it? If your x's all cancel out and it's true, what is it? Good job. All right. The rest of the time you should be getting an answer for x. Okay. Let's look at real quick this thing called literal equations. Last thing of the day. All this means is that you're going to have variables left in your answer. The most common literal equations that we've ever done are ones like this, where we had 3x plus 2y is equal to negative 12, and they told us to solve for y. This is the most common one, the one we've done the most of. Yeah, get y by itself. That's all this means. Literal equations just mean get the variable that they ask for by itself. So how do I do that? Okay. When I do that, are 3x and 12, are they like terms? No, so they can't go together. So I'm going to write it as negative 3x minus 12. Remember, we usually, and the last thing I'm going to do is divide by 2. Remember that we the general accepted way of mathematicians doing this, you put the variable part first. When we subtract that 3x and get that solution there, put the x part in the front, and then divide by 2 is the last step. And that doesn't go evenly, so I'm just going to leave it 3 over 2. And then 2 goes into negative 12, negative 6 times. And it's a slope-intercept form equation is what that ends up being. That's what we've done the most of, but it's not necessarily the only type of literal equation. But we've done the biggest part of our problems in life. We've in algebra class anyway. We've done it that way. Let's look at a different equation. Maybe go back to your geometry days. Well, this is not too bad. It's just what formula is this? Circumference. Good. Let's solve that thing for r. 2 times pi times the radius. Okay. So what's going on between the 2, the pi, and the radius? Multiplication. So the opposite of that to get rid of it would be divide. What am I going to divide by? 2 and the pi. And we're just going to leave it that funky looking fraction, c over 2 pi. And that's what r is equal to. Let's do another geometry. Okay, usually A is area, and it is in this case. What's that the formula for? Area of what? Triangle. So we're going to solve that for h. So, okay, so dividing by 1/2 is the same thing as multiplying by 2, the reciprocal, right? That's going to be 2a is equal to bh. And then the last step would be divide by b, right? Why am I not wanting to write a b, right? So 2a over b. I almost think the literal ones are easier because you don't have to work much out. You just got to move some stuff. I may be wrong, but that's the way I think about it. I don't think like everybody else does. All right, one last formula. Go back to your geometry days. N minus 2 in parentheses times 180 is equal to, that's a capital S. And we want to solve that for n. Anybody know what that formula is for? Not surface area. Good guess though, because the S there. That's S. You use surface area as S equals something. It's the sum of the interior angles of a polygon. You know, ever how many sides it's got? You take the number of sides minus 2 times 180. So like if you have a square, 4 minus 2 is 2. 2 times 180 is 360. The angles inside of a square add up to be 360. If it's a pentagon, it's 5 minus 2. If it's an hexagon, yeah, it's all, yeah, that all works. So that's what that formula is for. Not necessarily that you have to know that for Algebra 2, but that's where that formula comes from. And I always think general knowledge is good. So what are some options for solving this thing? There's a lot of ways to work this one, but there's some options. I heard somebody whisper. That's what I heard, and I don't know where it came from because it's so quiet. So is distributing an option? On the right-hand side, what's going on? You got a parentheses and a number on the outside, right? Isn't that distributive property? Isn't that what that looks like? It's backwards. We're used to seeing that 180 in the front, right? But it's still distributive property, even though that 180 is in the back. So that's not a bad idea. Let's try that. 180 n minus 360. Well, still not got an n by itself, but okay, I could add 360 to both sides. That's a good idea. 180 plus S plus 360. All right, last step would be dividing by that 180, and that would get us N by itself. What am I going to divide by 180? Just 360? Both of them, the whole thing. So S plus 360 over 180 is equal to N, or S over 180 plus 2. Why are they both correct? Yeah, if I divide each one individually by 180, that's where the 2 comes from. I would take either on that problem as far as that goes. Okay, so solving equations, get the variable that is in the problem. If it's a regular equation, just get the variable by itself and you're done. If it's a literal equation, then get the variable they ask for, and they're going to tell you in the directions which